watching a video about brominated flame retardants. Never heard of them? Well, let's take a look at what exactly brominated flame retardants are.
Brominated flame retardants save thousands of lives every year. They are substances which will make the difference between life and death or severe injury. If there's a fire in your house, which starts from a television or a computer, it will be the brominated flame retardants which will give you and your children enough time to escape from the house.
So how do they work? And what are they made of?
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium.
Remember when you studied this at school? It's the periodic table. These are all the chemical elements. Did they seem a threat to you then? Or did you feel that they were just natural elements? These days there seems to be a lot of confusion and misinformation about some of these elements. It's easy and actually quite fashionable to say that they are all bad and all dangerous. Some environmental groups want to ban whole families of them.
There's holmium and helium and hafnium.
So should we try to create some order out of all this chaos? Let's take a closer look at one of these elements, bromine. What is it? Well, like the better-known chlorine and fluorine, it's part of the group of elements called halogens. The most recoverable form of bromine is from salts found in seawater, salt lakes, and inland seas. Ever since bromine was discovered in 1826, its compounds have been used for a wide range of applications. To purify water in your local swimming pool, in pharmaceuticals, in agriculture. However, the most common use of bromine is in brominated flame retardants. They save thousands of lives every year. How? In today's world, we're surrounded by products made of highly flammable materials, like textiles, electronics, and more generally plastics. The use of brominated flame retardants in these materials increases their resistance to fire. If, for example, a non-flame resistant TV catches fire, you will have only 2 minutes to escape. By contrast, the flame-resistant one can provide you with up to 30 minutes of escape time, or even doesn't catch fire at all. That's why brominated flame retardants are commonly used in upholstered furniture, planes, and cars. You also find them in computers, mobile phones, and other electrical appliances. Every year, 5,000 people are killed, and 10 times more are injured in house fires in Europe. Imagine what that number would be without highly effective flame retardants. So we know they save lives, but are they dangerous? There are many different types of brominated flame retardants.
Some of the group have been shown to be unsafe to use. Those have already been restricted or banned. The remaining ones, I believe, have been very thoroughly risk assessed, and the risk has been demonstrated to be extremely low to negligible. And I think that the science as a whole demonstrates that they can be used safely.
So we should be using sound science as the basis for all decisions that we make on which substances are safe for use and which are not. Europe should trust its own science. But why then do some people still want to ban brominated flame retardants?
I think it's an historical thing. Once you believe that something is a problem, however much evidence you put together to show that it's not, there is still a tendency to believe there might be something there. Almost a no smoke without fire sort of argument. And you know, it is clear that there are residues of these things in the environment, which is highly undesirable. It was bad practice in the past. The fact that practice has got better now, to the point where I don't believe we are further contaminating the environment, doesn't alter the fact in public perception that there was contamination in the first place and a perceived risk.
Some tend to forget that there's a big difference between a hazard and a risk. For example, table salt or fluorine in your toothpaste, if taken in big quantities, are definitely hazardous. But the risk of that actually happening is minimal. Brominated flame retardants are no different. A hazard in unusually high doses? Yes. A risk? Well, no. Anyway, how good are the alternatives?
The alternatives have not been tested as much. That is true in the vast majority of cases. The hazard of some of the potential alternatives is low, or appears to be low. The risk appears to be low. But of course, if something posed no risk in the first place, an alternative is not going to improve the risk profile.
In the past, the EU has created separate chemical laws for different industry sectors or products. Then the new European chemical legislation, called REACH, introduced one common set of rules for the assessment of all chemicals. The producers of brominated flame retardants have taken all the necessary steps to comply with this new legislation. The main brominated flame retardants will easily be included in REACH on the basis of their extensive risk assessments. Sound science. Europe must trust its own science.